A bridge is a structure built to span physical obstacles such as a body of water, valley, or road. For the purpose of providing passage over the obstacle, there are many different designs that all serve unique purposes and apply to different situations. Design of bridge vary depending on the function of the bridge, the nature of the terrain where the bridge is constructed and anchored, the material used to make it, and the funds available to build it.
Bridge may be classified by how the forces of tension, compression, bending, torsion, and shear are distributed through their structure. Beam bridges are horizontal beams supported at each end by structured units and can be either simple supported when the beams only connect across a single span, or continuous when the beams are connected across two or more spans. A truss bridge is a bridge whose load-bearing superstructure is composed of a truss. This truss is a structure of connected elements forming triangular units. Cantilever bridges are built using cantilevers, horizontal beams supported on only one end. An arc bridge is a bridge with abutment at each end shaped as a curved arc. Arc bridges work by transferring the weight of the bridge and its load partially into a horizontal truss restrained by the abutments either side. A viaduct along bridge may be made from a series of arcs. Although other more economical structures are typically used today. Tire arch bridges have an arc-shaped support structure but differ from conventional arch bridges instead of transferring the weight of the bridge and traffic loads into thrust forces into the abutments. The ends of the arches are restrained by tension in the bottom third of the structure. Suspension bridges are suspended from cables. The earliest suspension bridges were made of ropes or vines covered with pieces of bamboo. In modern bridges, the cables hang from towers that are attached to caissons or cofferdams. The caissons or cofferdams are implanted deep into the floor of a lake or river. Subtypes include the simple suspension bridge, the stressed ribbon bridge, the underspanned suspension bridge, the suspended deck suspension bridge, and the self-arched suspension bridge. Cable-stayed bridges, like suspension bridges, are held up by cables. However, in cable-stayed bridges, less cable is required and the towers holding the cables are proportionally higher. El Puente de la Mujer. El Puente de la Mujer is a work of Spanish architect Santiago Calatrava in Buenos Aires, Argentina. It is the only one of his works in Latin America. The bridge components were manufactured by the company Ursa in the city of Vitoria, in the Basque Country, because the steel that was used is not manufactured in Argentina. All parts of the bridge were built in the city of Victoria, south of Bilbao, and moved to Buenos Aires to be assembled on site.
The bridge is a pedestrian element of communication that saves the separation between the Dock 3 in Puerto Madero from Avenida Alicia Moreau de Justo, the commercial area, to the east. Therefore presents an east-west orientation. In its closed position, the hair is oriented toward the west, running south in its position of maximum aperture board. The design is a synthesis of the image of a couple dancing tango, a man in a vertical element and the woman in horizontal element. It is a pedestrian bridge 160 meters long and 6.20 meters with 5 meters width, while split into three sections. Two fixed on both sides of a dam and that rotates on a mobile pylon cone of white concrete and allows less 2 minutes of the passing vessels. This central section is supported by a steel nettle with a sole of cement of about 39 meters in height. The nettle is ready to hang it diagonally like a suspension brake. The cable that supports the stretched torn.
The pedestrian bridge from Dock 3 forms a kind of bridge cable stay in parallel thanks to its system of rotation allowing the shipping dock. The width of the pedestrian bridge is 5 meters of free passage, and the central gauge is respected through a rotation mechanism that allows rotation of the central section of approximately 100 meters at an angle of 90 degrees. The distance to safe is reduced by two approach bridges located on both sides of the dam, working as the centerpiece cable stay bridge and rotary. Through a concrete pillar at the rear of the bridge, a structural balance between this area and the stretch cable stayed, simplifying significantly the rotation mechanism.
With asymmetrical variable section, the pylon constitutes the key concept for the understanding the structure and aesthetic of the bridge. The pylon is forming an angle of 38.81 degrees with respect to the horizontal and building from the battery to and the total height of 34 meters pylon stands up to the growing peak of the bridge of 35 meters on the board. Structurally, it consists of steel sheets with different thickness internal steel frames, particularly in the shoulder straps and anchors and its base. Along the stem of this element, the 19 cables are available in galvanized steel 15 millimeters in diameter behind the board. All concrete elements that remain in contact with water, cement was materials especially resistant to sulfur and sea salt in order to give the structural parts of strength and durability. Foundations and the three batteries that are of concrete and reinforced white. The footbright metal and its rear end concrete. The handrails are made of steel.